All right, guys, here we go. We got our lecture video 11.2, part 1. I believe this goes with assignment number 4. Whoops, that's not working too well. Assignment number 4, page 655, 11 through 31. Odds, and then 33 and 34. So that's our practice with that tonight. Okay? So I got this hat on today. It's a little cold in my room. AC's going. I told you to try to wear a different hat every day. You never know. So today, Trig, number 4. No review today. We got some intro stuff. We're going to work with 11.2. It's working with more trig functions. The 4 things we're going to cover today: sketch and standard angle, find coterminal angles, then we're going to convert radians to degrees, and then we're going to find the arc length. So as I get my arms and everything used to writing again, hopefully it'll clean up. So let's go ahead and just talk about just standard angles and the idea of excuse me, our trig functions and our trig angles. So we got some vocab we got to deal with. Let me color code this. So let's just draw this piece here. This is in purple, and then this here. These are connected. I'll draw this in red here. Let's just go like that. So this is one piece here. So the purple and the red are connected right there at the origin. This is our x-axis and our y-axis. So this is what's called the initial side. That's the initial side of this. And this is called the terminal side. Okay, so what this really means is this. The initial side stays here all the time. So this initial side is always here. And this red piece is kind of like, I don't have anything long enough. It starts here at 0 and then it opens up. So this red piece can be anywhere along. It just spins like a watch. Okay? So that's the basic idea. So the terminal side, the red side, can move anywhere. Okay? So it can move anywhere that we want it to move. It just keeps spinning. Now, with that comes an idea that the terminal side can end up at any degree. We start here. Remember, this is the starting point. It always starts here. So the terminal side always starts here, and then it finishes. That's why we get the idea of terminal side. It finishes somewhere as it rotates. And so we kind of rotate around to here. All right? So what this means is that the terminal side creates an opening that we call the standard position. It stops at a standard position. And then that kind of, and again, it can go anywhere, and it goes by angles. So we start here at 0 degrees. We go to 90 degrees, then it goes to 180 degrees, and then it goes to 270 degrees, and then it goes to 360 degrees. Because it creates a circle. I mean, if I keep going here, it's going to create a big circle, and circles have 360 degrees in them, and half of a circle has 180 degrees in it. So it has some major pieces of just kind of old stuff. Now, this terminal side can travel 2 directions. So if it travels counterclockwise to the left like this, that's a positive direction or a positive angle. If it goes clockwise, so let's write clockwise here. Oops. If it goes clockwise, it's in a negative direction. So negative direction. So if it's a negative angle, it goes this way, always from the start, And if it's a positive angle, it goes this way. It goes to the left, which is counterclockwise. All right, so we've got some quick ideas here. So let's just kind of look at some examples. So I'll go ahead and redo this in black. Let's look at black here. All right, look at that black one there. We've got 215 degrees. Okay, so we've got our here, got our y-axis. Now we can go in red over the top of the black x-axis and y-axis. So we start here always, and it says I wanted to do 215 degrees. 215 degrees. So I know that it starts at 0 degrees, it goes to 90 degrees, and this goes to 180 degrees, and this is 270 degrees. So 215 is going to go past 90, past 180, and a little bit past there. And that is my standard angle of 215 degrees. Okay? So that's the idea behind that. So let's look at another one. Let's look at negative 40 degrees. Negative 40 degrees. Draw my x and my y-axis. All right. And then negative tells me I'm going clockwise, so I'm going this way. So I start here at 0 degrees. This is going to be negative 90 degrees, negative 180 degrees, because I'm going the opposite direction, and this is negative 270 degrees. So I'm going this way. So therefore, I'm in between 0 and 90, so I'm going to come back like this. There's my negative 40 degrees. Okay? All right. That's the idea behind your standard position and different pieces like that. So let's just keep going with this, and we'll add a couple of more in there. What about, let's do 540 degrees. What about 540 degrees? Here's 540. Here's my starting point. Forgot to write my x-axis, my y-axis. Well, this is 90. This is 180. This is 270. 360. So if I start here and go all the way around in the circle, I'm at 360 degrees. If I go one more 90 degrees, I'm at 450 degrees, right? I think, I don't know. So if we do 360 plus 90 more degrees, that's 0, 5, 1, that's 450. And if I go another 90 degrees, it's 450 plus 90, 0, 4, 1, 540. I'm right here. I'm done. It lands on the axis, so that's my standard angle for the 540 degrees. So, let me throw a couple of them at you real quick. You can try them. So, you guys can do, real quickly, you guys can do negative 150 and 600. So I'll give you guys a few seconds to do those, and then I'll have you answer them. So if you want to stop the video, you can. If not, we can work with it. So negative 150 is going to be right about here. And 600, I'm going to go around once. That's 370, 360, that's 540, 600 is right about there. So that's my 600 right here. 600 is right there. Okay, so real quick on those, and I'll ask you if you got those right or you understood those too. So that's real quick examples of those. All right, so we got our idea of terminal side. So now we've got to decide a couple of different things, and I'm going to go ahead and erase this here. So they ask us the idea to find co-terminal angles. So how do we find co-terminal angles? All right, so first of all, we know what terminal means. Terminal means let's say we do 150. So it's really easy to do 150. It's right about there. This is 150 degrees. Terminal side, terminal means it's right here, 150 degrees. That's a terminal angle. That's what we just talked about, standard terminal angle, standard angle. So now the idea is this. I want a co-terminal angle. Co means the same spot, you know, cooperate, you work together. It means that it means the same exact spot. So the idea behind co-terminals is that I can get two new angles off of this one. How? I can go around 360 more degrees to there. So I can say a co-terminal angle is 300, is the 150 I started with, and then I go one more circle, which is 360 degrees. If I add those two together, I get 510 degrees. 3 plus 1 is 4, so that's 400. 300 plus 400. 60 plus 50 is 110, so 400 plus 110 is 510. That is a co-terminal angle. Co-terminal angles are equivalent. So 150 is the same exact spot as 510 degrees. It's right here. So if you did 510, you would just keep going around in a circle. Now, this is a positive co-terminal angle because it's positive. I need to find a negative. Change the color on this one. Let's go with green. Negative. I need a negative coterminal. Well, for a negative coterminal angle, I'm going to go ahead and erase this purple one for the positive. The negative means I'm going to go backwards. So I'm going to go one full rotation around the circle back to the same spot. So what do I get? We start with our 150. I'm going to change that to 150 here. 150. But I didn't go forward 360. I went backwards 360. So if I subtract those two, I get negative 210 degrees. So now I have a negative value coterminal and a positive value coterminal. So to get coterminal angles, you either subtract 360 to get negative ones, and you add 360 to get positive ones. And you can add over and over and over again. We can add another 360 to this, and then we can add another 360 to this. So those coterminal angles just land in the same exact spots. All right. We are now on to radians, converting radians. Here we go, guys. So if we're going to convert radians, we got to know what a radian is. So, radians. These are measurements, like degrees, but they're measurement of arc length. So what does that mean? So let's draw our x-axis. And let me just draw a triangle here. This. Let me do a purple color here. All right, so this is what a radian is. A radian is a measurement where the radius is equal to the arc length. So, in other words, if this is the radius r, and it is r long, then the arc length has to be r. So this here, since the radius and the arc length are the exact same length, that is equal to 1 radian. Okay? Now the circle is special, because every time we do that, and we come all the way around here, these keep matching up. So the length around this r right here, this arc length, is the same as this one here. And then if I do one more, I know it's not a very good drawing. It ends up, I'll even go farther down. It almost makes it. It almost makes it to the very end, but it doesn't quite make it. Okay? So this means that this is 1 radian. This one is 2 radians, because I have 2 radiuses of length all the way around. This one is 3 radians. Take a guess of how much farther that is right there. Hopefully you guessed 0.14. So what happens is that this, when the radius equals the arc length and you do that 3.14 times, you end up all the way around the circle. Well, 3.14 is the same as pi. So we always say that in a half circle there are pi radians. All right, so why is that a big deal? Well, we need to convert things sometimes. So we need to convert degrees to radians. So degrees are a unit of measure, and radians are a unit of measure, kind of like feet and meters. They're the same. They're the same. They measure the same things. They just do it with different values. The same thing with degrees and radians. So if I'm going to convert degrees to radians, I know that in pi radians, there's how many degrees? Well, it's a half a circle. So it's 180 degrees. So if I'm going to convert degrees to radians, I'm going to convert it using this. Pi radians per 180 degrees. That's what we said here. 3.14, which is pi, for 180 degrees. Because remember, half a circle, you start here at 0, half a circle is 180 degrees. So then what am I going to use to convert radians to degrees? Well, I'm going to use the opposite. For every 180 degrees, there are pi radians. All right, so here's my 2 conversion factors. These are conversion factors. So let's erase this here, and let's just kind of do a little bit of algebra for some. Let's take negative 30. Negative 30 degrees. This is in degrees. I want it in radians. So convert it to radians. So I'm converting degrees to radians. So I'm going to multiply it by pi radians over 180. So if I take this, You're going to have chemistry, you've had chemistry, this is the same idea. Pi radians has 180 degrees. So what happens is, I get a fraction. Negative 30 over 180 pi radians. I can't spell radians. This here converts down into negative 30. Well, actually it converts to 1/6 of a pi. Negative 1/6 because of that negative. How did I get to negative 1/6 of a pi? Let's do that real quick. You have negative 30 over 30 times 6 is how I can get 180. And then those simplify out, and I'm left with negative 1/6. That's how I got 1/6. Little fraction review. So that's how you convert degrees to radians. You just multiply by pi over 180 radians. Now let's look at converting radians to degrees. Let's look at that one. 5 pi over 2. And we're going to convert that to degrees. So we're going to take the same idea. We're going to multiply 180 degrees times pi radians. All right, let's kind of work with this here. So we can do all sorts of things. This is like a multiplication problem, so if you want to take this out, you can. And we're going to multiply two fractions together. If you multiply two fractions together, these will cancel out. 2 divides into 180 90 times. So on the top we get 5 times 90 over, oh, this is radians too. Radians cancel. 5 times 90, because this is gone, this became 90. 5 times 90 is 450 degrees. So that's my 450 degree angle, converting from radians to degrees. So let me throw 2 of them at you here and see if you can figure out what they're going to do. So you can turn off you can pause your video if you'd like. So those are the 2 that you can try and see how you convert from radians or degrees to radians or radians to degrees. So I'm going to convert this one first. Pi radians over 180 degrees gives me 120 degree, got it over 1 there, 120 degree pi radians over 180. And so what will happen is this will simplify out. Let me erase this one. This will simplify out to 2 pi over 3 radians. All right. What was that other one? Negative 3/8 pi. And we're going to multiply that by 180 over pi. Those are going to cancel. This is going to become a little bit of fraction work here. This is going to divide by 2. That's 4. That's 90. This will divide by 4. That's 2. That's 45. So let's work with that. So negative 3 times 45 all over 2. So I divided these by 4. This by 4 and that by 4. And then we end up with 100 negative 100, and did I write something down wrong? No, I didn't. Negative 135 over 2 degrees. Something doesn't feel right about that one, but that's what I wrote down, 3/8 pi. Yeah, that works. It is what it is. Here we go. So, That's it's a funky degree, and if you mess with that a little bit, you're going to get, if you divide that by 2, you're going to get 67.5 degrees. That's what you end up with. All right, our last thing for today, our last piece of the puzzle for today is finding arc length. So, if you're going to find arc length, here's the word arc length. So, we're going to be dealing with radians. So, we're only working with radians. Here's your formula. Arc length is equal to the radius times theta. Okay, so I have, this is my radians, that's in radians. This is my radius. And then all I need to do is multiply those together. So let's just take a wheel that has a radius of 33 inches. So my radius is 33. Okay? And let's say it makes 3/4 of a turn. So if this goes, let's say, find distance for 3/4 of a turn. So if it's find the distance for 3/4 of a turn, let's just assume it starts right here. If this turns 3/4 of a circle, it's coming to right there. 1/4, 1/2, 3/4, and it's going to stop. So what's my radian that it traveled? Well, we got to figure that piece out. So got a couple of things to do. You know that this is 0, 90, 180, 270. Well, we end up saying, okay, well, theta is 270 degrees, but I need it in radians. How do I convert to radians? Pi over 180. Oops, let me multiply that. So my theta is equal to, if we simplify this out, we get 3 pi over 2. 3 pi over 2 goes right here. And I get 99 pi over 2 radians. That's how far it traveled. It traveled 99 pi over 2 radians. So when you're finding the arc length, you got to convert your theta into degrees, and they'll ask you weird little questions like find the distance of 3/4 of a turn, and you'll have to do some conversion. Every one of these is different, so make sure you convert to radians. We deal with radius. We'll have to walk through a couple more of these problems, but that's the end of the video today, guys. We'll talk to you later.